Greetings once again, iCampSA students, and welcome to another video. In this video, we're gonna be doing a past paper question, and the question will be on trigonometry. This one is from 2018. Okay. So without wasting any time, let's get to it. In question 3.1 in the diagram below, triangle QPR is a right angle triangle. So right from the word go, once you are told that you are dealing with the right angle triangle, a few things that should pop in your mind that we can use trig ratios. You should be thinking about trig ratios, and I'm pretty sure you are familiar with the mnemonic or the abbreviation that we use to remind ourselves of the trigonometric ratios, which is SOHCAHTOA, and then with SO standing for sine is equal to the opposite side, or sine of an angle is equal to the opposite side over the hypotenuse side, and CA stands for cosine of an angle is equal to the adjacent side over the hypotenuse side, and then TOA is for tangent is equal to the opposite side over the adjacent side. Okay, and also another thing that should come to your mind is the Pythagoras theorem. I'll just say Pythagoras theorem is the Pythagoras theorem. And if you remember, the Pythagoras theorem is r squared is equal to x squared plus y squared. Okay, so whenever you are dealing with trigonometry, or you are dealing with trigonometry examples or questions, you should always be looking forward to use the what I've just listed here. Yeah, since you are still in grade 10, and this forms the base for everything that you're gonna be doing in the higher grades. Okay, so we've already read the statement, and we know that we're dealing with the right angle triangle, and then the angle QPR, this angle, we're told that it is 90 degrees, and then we have angle Q and angle R. Okay, and then next we are asked to use the sketch to determine the ratio of the tangent of 90 minus r. What is important to know here or to see is that, okay, r is this angle that we have here, r is that angle, and then according to the sum of the angles on a triangle, if we have that angle r, that means angle q is gonna be what? Angle q is gonna be 90 minus angle r. And how do we get there? I'm saying we are using the sum of the angles on a triangle, which is, let's just say, angle q plus angle r plus angle p is equal to 180 degrees. Let's solve for angle q. Angle q is equal to angle p, this angle you already know that's 90 degrees, is equal to 180 degrees minus 90 degrees minus angle r. Therefore, angle q is equal to 180 minus 90 is going to be 90 degrees minus angle r. Hence, I'm saying that this angle that they are referring to here, which is 90 minus r, is essentially angle q. So we need to determine the ratio for the tangent of angle q. So let's go ahead and do that. I said tangent is what? Is the opposite side over the adjacent side. And when we are looking at this angle here, at that angle here, q, this is the opposite side, and then this is the side next to the angle q, or angle 90 minus r. So therefore we're gonna have PR over QP. So for 3.1.1, the tan of angle 90 minus r is equal to the opposite side, which is PR over the adjacent side, since we are dealing with the tangent, which is QP. Okay, and then next we are asked to determine the trigonometric ratio that is equal to the side QR. QR is the hypotenuse side over the hypotenuse side over QP over this side QP. Okay, so from here what you need to understand, or what should come to your mind, is that QR is the hypotenuse side, and generally hypotenuse side is the denominator. But once now we see that the hypotenuse side is a numerator, that means we are actually using the reciprocals of the trigonometric ratio. Maybe to quickly remind ourselves of the reciprocals, we are in 3.1.2. I'm just gonna say trigonometric reciprocals. The trigonometric reciprocals, we have the reciprocal of sine theta, which in other words is called cosec theta. We have cosec, just gonna use the angle theta is equal to 1 over sine theta, and then we have sec theta, or secant theta, is equal to 1 over cos theta. In other words, it is the reciprocal of cosine theta. And then we have cot theta, which is the reciprocal of tan theta. Okay, so let's come here. We are looking at what now? At QR over QP. So the trigonometric ratio of what? Of the hypotenuse over the adjacent side when we are looking at the angle Q. So if we are using 90 minus R as our reference angle, we're gonna have the reciprocal of cosine, because it is cos that relates QR and QP. So we can start by writing the cosine trigonometric ratio, which is cos 90 degrees minus R is equal to QP, the adjacent side, over QR. But see, now we are looking for QR over QP. Therefore, what is the reciprocal of cos is sec. So sec 90 degrees minus R is gonna be equal to QR over QP. This is what we were looking for. So yes, by using that reference angle, we're gonna have sec 90 minus R. Okay, and then from there let's go to 3.2. Then for 3.2 we are told that S with the following coordinates of -3 and -4 is a point on a Cartesian plane such that OS makes an angle of theta with the positive x-axis. Okay, without using a calculator, calculate the length of OS. Okay, so we know that at O, the coordinates of O is 0 and 0, since that is the origin. So we can calculate the length of OS by using the distance formula. The distance formula, since we have the coordinates of O 0 and 0, we have the coordinates of O 0 and 0, and we have the coordinates of S, which is -3 and -4. So let's quickly do that. 3.2.1 3.2.1. To calculate the length of OS, we're gonna use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, and then the coordinates that we are dealing with is O and S. Let's quickly write them down. We have coordinates of O, which is 0 and 0, and we have the coordinates of S, which is negative 3 and 4. Yes, negative 3 and negative 4 and negative 4. Okay, so let's quickly plug in our values. Okay, let's take negative 3 minus 0 squared plus negative 4 minus 0 squared. This will give us the length of OS. Therefore, OS squared is equal to negative 3 squared is gonna be 9 plus negative 4 squared is gonna be 16. Then we introduce the square root on both sides. Therefore, OS is equal to 9 plus 16 is 25. The square root of 25 is 5 units. 5 units. And there we have the length of OS. And then from there, after calculating the length of OS, we are asked to calculate the value of sec theta. Remember that sec theta is the reciprocal of what? Is the reciprocal of cosine, and then sine squared theta. Maybe before we go any further, let's determine the ratio of cos theta. Is going to be what? It's going to be, remember, we have negative 3, which is our x value or the adjacent side, and then we have negative 4, which is our y value, and then we have r, which is our hypotenuse, side that we have just calculated, which is OS, and we find it to be 5 units. That's our r, which is 5 units. So the ratio of cosine theta is gonna be, what's the adjacent side? The x value is negative 3 over 5. Okay, and then therefore for the sec theta is going to be negative 5 over 3, since we take the hypotenuse side or the denominator and we make it the numerator. Okay, and then the ratio of sine theta is the opposite side, which is y over the hypotenuse side, so it's going to be negative 4 over 5. That's the value of the sine trigonometric ratio. That's the ratio of the sine theta. Once we have this, we can actually go to 3.2.2 and determine the value of sec theta plus sine squared theta. So for 3.2.2, we are asked to determine the value of sec theta plus sine squared theta. This is going to be equal to sec theta. We calculated cosine theta and we find it to be negative 3 over 5. So the reciprocal is going to be negative 5 over 3. We take the denominator and we make it the numerator. So the reciprocal, which is sec theta, is going to be negative 5 over 3. Plus the ratio of sine theta, we take it as it is. It's negative 4 over 5 squared. So we're going to have negative 4 over 5 squared. This is equal to negative 5 over 3 plus negative 4 over 5 is going to be 16 over 25. And then let's quickly punch this in our calculator. It's negative 5 over 3 plus 16 over 25. I'm getting negative 77 over 75. Negative 77 over 75. That is the value of that ratio. Okay, and then determine the value of the following without using a calculator: the value of cosec 45, sine 90, and tan 60 degrees. Okay, so here what is important for you to realize is that we are dealing with special angles. We are dealing with special angles. So I hope you do remember the special angles. So for cosec, we can change the cosec 45 to 1 over sine 45, and then we just determine, without using the calculator. So for 3.3 we have cosec 45 over sine 90 degrees multiplied by tan 60 degrees. So I can write the table for the special angles, but it's gonna take a little bit more time. So what I'm gonna do, I'll just look for the table or the Venn diagram of the special angles, and then I'll paste it here. Then we'll continue solving for this using the special angles. Okay, so there we have our picture for the special angles. I hope it's visible enough. Okay, so before we start plugging in the special angles or the ratios for the special angles, let's start by changing cosec 45 to 1 over sine 45. So we're gonna have 1 over sine 45 degrees divided by sine 90 degrees times tan 60 degrees. Okay, so and then what is sine 45 degrees? Sine 45 degrees is 1 over root 2, so we're gonna have 1, okay, I can just write it in this form, 1 divided by sine 45, which is 1 over root 2, and then in the denominator we have sine 90. Sine 90 is actually equal to 1, so we're going to have 1 times what is tan 60. Tan 60 degrees is actually just root 3. It's root 3 here, and then this is equal to 1 divided by 1 over root 2, we're just going to have root 2 in the numerator divided by root 3, and then you're gonna leave your answer in this set form. Okay, I think that marks the end of our of this question 3 on trigonometry. So that's how you approach your exam question, guys. Always remain calm and try to understand what is being asked of you, and also try to use what we have learned over time to answer these questions, because you are tested on something that you already know. It's just that some of you, when it's time for the exam, you panic, and sometimes you end up failing to apply what you know in order to get what you don't know, because with mathematics you'll always have to use what you know in order to get what you don't know. If you are being asked to calculate the gradient of a line, you know the equation for calculating the gradient, so use the equation to calculate the gradient to find the gradient of that line, So anyway, guys, thank you for watching this video, and make sure to keep on following us, and also practice. I wish you good luck on your exams.